Hello, Kim 121. This is Professor Ship, and today we're going to discuss density. So I've titled this, Why Be So Dense? The chemistry behind density. Density, of course, depends on how tightly packed matter is and the amount of mass in a given space. So, for instance, if you notice that you have less density on the left versus the right, when you deal with gases to liquids to solids, density will be compact accordingly. So if you have a gas, density has more is there's more room for it to move around. But when you get to the liquid, things tend to get a little bit more compact. But once you get to that solid state, that's when everything is squished together and everybody's fighting for their space. Now, if you look at this particular screen, you will notice that there are different density examples based on them being a solid, liquid, or a gas. So if I look at my density substances of solids like ice, rubber, magnesium, iron, gold, lead, notice those values are given in grams per centimeters cube or grams per milliliters. Liquids, same thing, and you have gases. Now, if I were to ask you to rearrange this particular chart, all you would have to do is put the lighter objects on the top and the heavier items based on their density values on the very bottom. So, for instance, if I tell you to compare, let's say, gold right here, okay, to let's say oxygen, okay? What's going to be on the top if we were to put these two in, let's say, a graduated cylinder? What would actually go on the very top? Would it be your oxygen or your gold? If you said oxygen, you are correct. Okay, so when we talk about comparing density values, we have to look at the numbers that are given, and those numbers are calculated according to their mass and their volume. Okay, so there we go. Trying to get the E in there. So as you take a look at, let's say, ice, and let me see here. If we take a look at, let's say, ice, and let's say water, what typically happens when we combine those two in a graduated cylinder? Where does your ice typically go? If you said it goes to the top, you are absolutely correct. Because if we look at our density value of ice, the number is 0.917 grams per centimeters cube. But when we look at the density of water, it is 1.000 grams per milliliter. Obviously, the less dense the item is, the lighter it will become and it will actually float. The more dense something is, it will actually sink. Okay? Let's take a look at another example. Here is how density can apply to the real world. You'll notice here that you have vegetable oil on top, water is in the second layer, dish soap is the third layer, corn syrup is the fourth, and honey is on the very bottom. If I were to ask you to write a sentence on what you observe, what you could easily say is that the honey is more dense than, let's say, the vegetable oil. Vegetable oil is less dense than honey. Water is more dense than vegetable oil. Water is less dense than dish soap. Corn syrup is more dense than dish soap, but less dense than honey. Like there are so many different ways that you can actually describe what you see. Now, if we go here, we can also use blood alcohol levels. And there is one example in your notes that you're going to have to use in order to calculate density using blood alcohol levels. And what you will notice here is that your blood alcohol levels are given in grams per deciliter. So in other words, the mass unit per volume unit are your density units, okay? So you can look at those numbers and you can use those to actually provide calculations. So if I told you, let's calculate the density of this blood alcohol level of 0.08 grams per deciliter to, let's say, milligrams per deciliter. All you would have to do is convert that first number of 0.08 grams to milligrams. It's that easy. So we're going to get into those today. So as you can see here on your screen, these are some examples of blood alcohol when it comes to law enforcement, because even law enforcement officers have to know how to calculate the blood alcohol levels of potential DWI and DUI offenders. So if you take a look here, we know we do not want you to drink and drive, but if you take a look at these examples here, we're going to actually practice those right now. Let's start. In order to understand how to do density problems, you first need to know what is density, how is it used, and what units are associated with density. So I am going to give you the formula for density, and we're going to actually practice some skill sets to give you confidence as you do these density problems, okay? So there are a couple of things you need to know. So what you see on your screen are examples from your notes, and we're going to talk about what density is and how it is used. So let's go ahead and switch the screen over to your notes. Okay, so you want to know what is density. So this is the formula that you need to know for density. D equals M over V. Okay, now in terms of how it's used, we use it based on those examples that I just gave you on the previous slide. So I'm going to actually go in a little deeper and give you some further examples to help provide clarity on how you use this. So when we talk about density, we have D equals M over V, okay? We also have mass, which is equal to density times volume. And then for volume, it's equal to mass over density. Now, in terms of the formula, something else I've used in the past with my students, I have also given them this as an example that they can actually help to remember this by. So let me clear the screen off a little bit, okay, to give you all some space right here. And what we've used before is this pic right here where the M is on top, okay? And then you have density and you have volume. So for instance, if I cover up my M, okay? Well, let me start with D, I'm sorry. Let me start with D. If I cover up my D, then my formula that's left is M over V, okay? So that's how you get the density formula right there, where I say D equals M over V. However, if I cover up my V, okay, let me go back and erase this right here. Let me do that. Okay. And if I decide, I'm going to find my formula for volume, let me go back and redraw that pic again so you can see how it's worked. Okay, so here's the pic again. So if I cover up, let's say the V this time, what do I have left over? Is M over D. So therefore, that would give me my formula for volume, which is equal to mass over density. And of course, as you know, if we cover up the M, you're left with D times V. Okay? So my mass in this case would be D times V. Now, here's the other part that you need to know. What units are associated with mass? We have things like grams, kilograms, centigrams, micrograms. Anything with a gram, okay, is associated with your mass. Volume, on the other hand, are things like milliliters, deciliters, liters, cc's, centimeters cubed. And I want you to remember this little acronym here, that whenever you see cc's, because I'm sure many of you all have seen this before in your nursing program or you work at the hospital, cc's is actually equal to milliliters, which is also equal to centimeters cubed. How fascinating is that? If you look at a word problem and you see cc's, but they want you to calculate the final answer in milliliters, just remember to substitute those units, okay? It's that easy. Now, the other thing I need to show you is when you talk about density and the units that are associated with density, look, all you have to do is combine two units of your mass and your volume. Let me show you. By combining your grams and your milliliters right here, okay, you're going to end up with grams per milliliter. Or let's say I wanted to combine, let's say kilograms and liters. Then I would have kilograms per liter. Or let's say I wanted to combine micrograms per deciliter. Then I would have micrograms per deciliter. So in other words, your density units are based on whatever your mass unit is over your volume unit. Okay? It's that simple. But let me give you some perspective though. Let me show you. If all I'm doing is combining a mass unit per volume unit, those things could vary. Again, I could have grams per milliliter. Okay? I could have grams per cc, grams per, let's say, liter. I could have, let's say, kilograms per deciliter. Let's say kilograms per centimeters cubed. In other words, you're going to have some type of mass per volume. Okay? So don't overthink that process. Just remember your units. Now, we're going to scroll on down and I am going to give you some further examples here. Okay? Let's go. Now, in order to determine the correct unit that you're going to work with, you have to consider what units have they already given you. So in the examples that I have here that I'm going to go through right here and right here, okay, I am going to show you how simple it is to determine what units are going to be in your final answer. So let's say that we gave you the formula for volume, which is mass over density. Okay? In order to know what your final answer is going to be in terms of the unit, all you would have to do is cancel out the like terms. Kilograms are canceled out, so you're left with milliliters. So remember, you're going to plug in your mass unit and your density unit, cancel out the two units that look the same, and you're left with the final unit of milliliters. Let's look at another example where you're calculating volume, and I give you grams for the mass, and the density is grams per liter. Well, my two G's are going to cancel out, and I'm left with a liter. So my final answer will be in liters. But let's take a look at this next example, where you have milligrams on top, but you have grams per liter on the bottom. Well, in this case, I can't cancel anything out because none of the units match up. So what you would have to do in this case is convert the milligrams to a gram. And then the gram per liter still remains on the bottom. And guess what you're going to do with those two units? They're going to cancel each other out, and you're left with a liter as your final volume unit. Got that? Let's take another look at the example of dealing with mass. You know your formula for mass is equal to density times volume. Okay? Density times volume. So here's the first example. Your density unit is kilograms per milliliters, and your volume is milliliters. Well, you know what the two units you can cancel out are? Milliliters. So your final answer when you calculate it would be in kilograms. Let's look at the next example over here. You've got kilograms per cc's, and then you have milliliters. Well, I don't see any units that match up. Well, yes, I do. As a matter of fact, I see cc's, and if you remember from my previous example, cc's and ml's are the same equivalency. So I'm going to cancel out my cc's and my ml's, and my final answer unit will be in kilograms. See? As long as you remember that, you're going to be fine. Let's look at the last example here, where you deal with mass. Again, density times volume. Well, my density unit was grams per liter, but my volume unit was in milliliters. None of these can cancel out. So in this case, you're going to have to make sure that you convert your milliliters to a liter. And once you do that, then your liters will cancel out. And guess what? Your final answer will be in grams. So let's go ahead and plug some numbers in these problems so we can find out how to calculate density, volume, and mass. All right, so you've got some density problems. The first problem says calculate the density, okay, right here, of an object. Now, here's what you're going to have to do first. Remember, above this sign right here, you're going to plug in your formula. Okay, so let's go ahead and plug that in. All right, density. So I know my formula for density is D equals M over V. And above that, I know I'm going to be working with 2 units as my final answer. Okay, in my final answer. So over here, we're going to go ahead and do the first problem. Notice that they give you the mass of 12.2 grams and the volume is 3.43 milliliters. Okay, all you need to do is plug this in, M over V. The mass was 12.2 grams over 3.43 milliliters. You must be aware of the fact that significant digits is in this problem. Okay, so we can't forget about that because all of your homework will be involved having to calculate significant digits. So in this first example, I've got 3.43 and 12.2. Well, both of those have 3 significant digits. So you know what my final answer is going to have, right? You guessed it, 3 significant digits. So let's go ahead and calculate that out. When I divide 12.2 by 3.43, on my calculator, I get 3.556. But now you remember, if the significant digits rule is in check, you know that you only need 3 of those. So I put a little dot above the third digit. That 6 tells this 5 to go up to a 6. So my final answer is going to become 3.56 grams per milliliters. Okay? That's going to be your answer for the very first one. Again, you cannot forget about your significant digits rule because that plays a role in this particular example. In fact, all of these examples. Now, let's move on to the next one, letter B. Here you're given the mass of 9.23 grams and the volume of 6.23 centimeters cubed. How will we calculate this problem? Let's try it out now. We know that our formula is D equals M over V, so therefore I'm going to plug in my first number, which is 9 point, uh-oh, 9.23 grams divided by 6.23 centimeters cubed. Well, now remember, 3 significant digits are on the very top, 3 significant digits are on the very bottom. So when I divide those two numbers, I get in my calculator 1.481 grams per centimeters cubed. Now remember, we only need 3 of those numbers. So I put a little dot above the 8, and that 1 tells this 8 to stay put. So my final answer becomes 1.48 grams per centimeters cubed. Okay? That is your final answer. And remember, you have the answer key nearby. If you scroll on down to the very bottom, you will see the answer key. Okay, so don't forget. Now, let's move on to the next example, volume. Now remember, in this block here, we're going to put our volume formula, and above it, we're going to put how many units are associated with volume. Okay, let's try it out. Okay, so we're going to try our hand at volume problems. So over here, I know that volume has 1 unit. Okay, and my formula for volume is V equals mass over density. So what I'm going to do is take my formula and just plug it in over here again. I know some of you, I may say that's repetitive, but I do that to keep that formula in mind. Now, my formula is going to have my mass unit on the very top, which in letter A, they gave me 14.45 grams over my density, which is 0.982 grams per milliliter. Now remember, if you recall, the units for volume will only have 1 unit provided, and it's going to be whatever the volume unit is in the problem. So as I look at this particular example, I know that my G's are going to cancel out. And when my G's cancel out, that leaves me with milliliters. But before we even put that as our final unit, let's look at our numbers. We've got 4 significant digits on the very top, 14.45. But on the very bottom, we have 3. Remember that 0 doesn't count, but the moment you get to that decimal and anything that goes after it does, so we have 3 significant digits on the very top. Well, our final answer should have 3 significant digits in them, okay? So I'm going to go ahead and plug this in. I've got 14.45 divided by 0.982. Now my calculator gives me 14.71, but we're going to stay right there at 14.7 milliliters. That is our final answer for letter A. All right, let's move on to letter B. Let's erase our screen to get to letter B. Okay, so for letter B, again, going back to that formula, V equals M over D, we know that our mass is 11.67 grams. And on the very bottom is our density, 2.90 grams per centimeters cubed. Now remember, on the very top we have 4 significant digits. On the very bottom we have 3. Remember that 0 counts because it is after a significant number and there's a decimal present. So now we're going to go ahead and plug those numbers in. We've got 11.67 divided by 2.90, and I get 4.02. Okay, 4.024, but remember we only need 3 of those. Let's go back to our units. We're going to cancel out our grams, and we're left with cubic centimeters as our final unit. Okay? So it's real simple. All you got to do is remember, what formula am I going to use? Where do the numbers go? Top or bottom? Cancel out my like terms, and I am done. All right? Let's move on to mass. This is our last formula here. Remember, we have, again, 1 unit for mass. Mass is equal to density times volume. So now we're going to go over here and we're going to plug that in again, D times V. Now for the first example right here, I know that my density that they gave me in the problem is 3.91 grams per milliliter. Let me write that up here, 3.91 grams per milliliter. Okay, I'm going to put that in brackets times the volume, which is 14.45 milliliters. I can automatically go ahead and cancel out my milliliters. Boom, boom. Now I've got 3 significant digits in 3.91. I've got 4 significant digits in 14.45, but I know that I should have 3 significant digits in my final answer. So when I plug this into my calculator and say 3.91 times 14.45, I get 56. I'm going to write these numbers out, 4995. Now remember, I only need 3 of these numbers right here. So I put a little dot above the 4. That 9 tells that 4, raise on up to a 5. So I end up rounding off to 56.5 grams. All right? Questions. If you have questions about this, make sure you put them down in the comments below, or you can email me your questions, okay? Let's move on to letter B now. Let's clear the screen and move on to letter B. Now, as we look at letter B, we need to plug in the numbers again, and we know the density was 0.791 grams per milliliter times volume, 10.0 milliliters. Remember, our milliliters are going to cancel out. And so we're left with grams, okay? Now, here we have three significant digits, 0.791. And right here, we also have three significant digits. Yes, 10.0. So our final answer is going to only have three significant digits. Now, when I multiply those numbers out, this is really easy. We get 7.91 grams as our final answer. Okay? Now, on a separate screen, I'm going to do problem 4, which deals with two different units based on two different types of problems, okay? So I'm going to pause this video and I'm going to set this up as part 2, so this video won't be too long, okay? So when you look at these problems, I want you to go back and you're going to find the video that says calculating density based on blood alcohol content. All right? See you soon.